ABCD is a trapezium in which AB parallel to CD, BD is diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F so that the F is the midpoint of BC. Okay, write the given and to prove. So how we are proving this? So you take the triangle ABD. So where E is the midpoint of AD and we know that EF is parallel to AB means, and let us say EF also intersect BD at X. You apply the converse of midpoint theorem for the triangle ABD. Okay, the line which is drawn from the midpoint of side ADE, okay, which is parallel to the side AB and also which bisects the other side BD at two equal arcs. Means here E is the midpoint of AD, EF is parallel to AB and EX also parallel to AB. So X is the midpoint of BD. So by converse of MBD we can say this. X also midpoint of BD. How you are saying this? Already you know that this is a midpoint of the side AD. It is given. E is the midpoint of the side AD. It is given. The line which is drawn from the E, that is EX, which is parallel to the second side AB, and also it bisects the other side BD. Okay, that means here X is the midpoint of BD. Can I say like this? X is the midpoint of BD. Okay, by converse of midpoint theorem, we can say this. Now you take the triangle BCD. This is the triangle BCD. Okay, so here which one is already we proved this. X is the midpoint of BD. The line which is drawn from the XF, it is parallel to the CD. How it is parallel to CD? We have written here. XF is parallel to AB and AB also parallel to CD. The line which is parallel to the same line are parallel to each other. That means here XF also parallel to CD. Therefore, we can say that here F is the midpoint of BC by converse of MPT. Hence, it is proved. And then in the next one, in a parallelogram ABCD, E and F are the midpoints of the sides AB and CD respectively. Show that the line segment AF and EC trisect the diagonal BD. You write the given and to prove. And in the proof, now you see, so we need to prove here dP is equal to PQ and PQ is equal to QB. For that, you need to take the two triangles. One is DQC and other one is APB. Okay, so you have to apply the converse of midpoint theorem for this. So before that, we need to prove, and these two lines are parallel. These two lines are parallel. For that, what we are doing now? Already it is said it is a parallelogram. So from this parallelogram, already you know that AB is parallel to CD and AB also equal to CD. So where F is the midpoint of CD, E is the midpoint of AB. So half of the AB, half of the CD will give the lines AE and CF. AE and CF. So therefore AE CF is a parallelogram. A pair of opposite sides are parallel and equal. Therefore we can say that this AE CF is a parallelogram. Okay. So from this, what you have to take, what you have to do now? So you have to take the triangle DQC. Now you see, I am taking the triangle DQC. In this triangle DQC, already it is given that F is the midpoint of the side CD. Now the line which is drawn, drawn from the F, okay, which is parallel to the third side QC and also it bisects the DQ. So the same thing we have written here. What is that? Here F is the midpoint of CD. FP is parallel to CQ. Already we proved. Why? Because since here AECF is a parallelogram. Okay, in parallelogram, the lines are parallel. FP and CQ are the parallel lines which are included in the AECF parallelogram, right? So where here, so from this we can say that FP is the midpoint of DQ by converse of midpoint theorem. So what is the converse of midpoint theorem? The line which is drawn from the midpoint, which is parallel to the second side and also it bisects the third side. Means here P is the midpoint of DQ, that indicates DP is equal to PQ. Now you take the triangle APB. In this APB already you know that E is the midpoint of the side AB and the line drawn from the E that is EQ, which is parallel to the line AP, and also it bisects the other side, means it bisects the BP. Therefore, we can say that this Q is a midpoint of the line BP. Okay. From this, we can say that PQ equal to QB. Now you see the from equation 1 and equation 2, and these two are equal. Why? Because both are equal to the same thing or equal to each other. So the way, from this we can say that DP also equal to PQ and PQ also equal to QB. Hence we can say that AF and CE are trisect the BD. Is it clear, everyone? Okay. Thank you for watching. Please subscribe Samyan's Academy.